Welcome all. In last lecture we have seen different types of multiplexers. Today we will see the applications of multiplexer. It is used as a data selector to select one out of many data inputs, as we seen earlier in the types of multiplexer. It is used for simplification of logic design. It is used in the data acquisition system. It is used in designing the combinational circuits. In the next part we are going to learn how to design the combinational circuit using multiplexer. We have already studied how to draw a combinational circuit using logic gates. Now here we are using multiplexer to draw a combinational circuit or to design a combinational circuit. It is used in digital to analog converter. It is used to minimize the number of connections in a logic circuits. These are the applications of multiplexers. Now we will see the study of different multiplexer ICs. We will see one by one. This is first one is 74157. It is a quad 2:1 multiplexer. It means that it is having 4 2:1 multiplexer inside a single IC, and the output is going to be available same as that of input. That is, we will not get any inverted output with respect to available input. So we will get input as it is over the output line for this IC 74157. Again, the second IC is 74158. It is also a quad 2:1 multiplexer IC. It means it is having 4 2:1 multiplexer available over a single IC, single chip. The only difference between these two is that here we get inverted output. It means if a data available over the input line is 0, we will get 1 output. If data available over the input line is 1, we will get a 0 output. Now next IC is 74153. It is a dual 4:1 multiplexer IC. Means it contains two 4:1 multiplexers onto the single chip, and its output is same as that of input. Means if a selected line is having 0 input, we get a 0 output. If a selected line is having 1 input, we get a 1 output. Means no inversion is available on the output line. The next IC is 74352. These two ICs are same. Both are dual 4:1 multiplexer. Means in this also 2 4:1 multiplexer ICs are available. Multiplexers are available, but only we get inverted output for the 74352 IC. It means if selected line is having 0 input, we get a 1 output. If selected input is having a 1 input, we get a 0 output, inverted output, that is. Now next is 74151A IC. It is a 8:1 multiplexer IC. We get complementary outputs for this. Again, another IC is 74152. It is also 8:1 multiplexer IC. Here also we get inverted outputs. And the last one is 74150. It is a 16:1 multiplexer IC, and in this we get inverted output. Means a 0 input is appear as a 1 and a 1 input is appear as a 0 on the output line for selected input line. Now we will see the pin configuration of IC 74151. This is a 8:1 multiplexer IC which is having 8 inputs. Here there is a notch is available. In this it is not shown. It is a 16 pin IC numbering from 1 to 8, and 9 to 16. Contains 8 inputs are at pin number 1 to 4 and pin number 12 to 15. That is D0, D1, D2, D3, D4, D5, D6, D7. These are the 8 inputs. Here it is D0 to D7, not 15 for this IC. Again, as this IC is having 8 inputs, so there are select line, that is 3 select lines are available, S0, S1, S2 at pin number 9, 10, 11. Again, this IC is having 2 output lines, Y and Y bar at pin number 5 and 6. Actually, multiplexer is having only one output, but here there are 2 outputs, means at pin number 5 we get normal output and at pin number 6 we get inverted output of the same output, means both are same, one is normal output, another is inverted output. It means that if we having select line status as 0 0 0, so in that case a D0 line is get selected. If D0 contains 0, we get a 0 output at pin number 5. At the same time we get a logic 1 output at pin number 6, that is inverted output. If D0 line is at logic high level, in that case we get a logic high output at pin number 5 and a logic 0 output at pin number 6 at the same time. Again, pin number 7 is a active low enable input pin, means we have to provide a logic 0 input to this pin number 7, by which this multiplexer IC gets enabled. If we connect enable input to logic 1, then irrespective of available input, irrespective of status of select line, we get a by default 0 output. So make sure that you have to connect the enable input pin to the ground or to the 0 so that it can get operated. And last is pin number 8 and pin number 16, which are the power requirements of these ICs. So we have to connect a pin number 8 to the ground, that is to the logic 0, that is at 0 volt, and pin number 16 we have to connect to the plus VCC, that is we have to connect it to the plus 5 volt power supply. So this is how a pin configuration of IC 74151 is helpful when we perform the practicals in the laboratory. Next, this is a functional diagram of IC 74151. Here 8:1 multiplexer, 74151 is the 8:1 multiplexer, which is having 3 select inputs S0, S1, S2 and 8 data inputs from 0 to 7. From this, pin number 1, 3, 4, 6 are connected at logic 1 and pin number 0, 2, 5 and 7 are connected to logic 0. That is, inputs are provided to the 8 data lines. Again, there are 2 outputs are shown, W and Y. One is normal output and another is inverted output. Y is the normal output and W is the inverted output. Strobe input is connected to the ground, that is it is active low input, that is it is a enable input terminal by which this multiplexer is going to be operated. Now the truth table is shown over here. C, B, A are the our select input lines. First case, select that is strobe input is 1, therefore irrespective of status of select line we get a 0 output, and its complemented output we get our a W line. For first case 0 0 0, status of strobe input is made available at logic low level, by which it gets enabled, and for the first case a D0 line is selected, that is 0th line is selected. As 0th line is connected to logic 0, we get a 0 output, that is the data available over the D0 line, and its complemented output onto the W output. In the same case, with respect to the status of select line, we get the selected output over the output line. This is how we can perform the practicals using this functional pin diagram and truth table in the laboratory, and we can verify this truth table as per our observations during the practicals. Now next is the multiplexer tree. The multiplexers are having more number of inputs, can be obtained by cascading 2 or more multiplexer with less number of inputs. This is called as a multiplexer tree. Means we can obtain 4:1 multiplexer using 2:1 multiplexer. We can obtain 8:1 multiplexer using 2:1 multiplexer or 4:1 multiplexer. Again, we can obtain 16:1 multiplexer using 4:1 multiplexer, 2:1 multiplexer and 8:1 multiplexer. Any of the multiplexers can be used to get 16:1 multiplexer. Means we can obtain a multiplexer having more number of inputs with the help of multiplexer which are having less number of inputs. This is we have to design in case of multiplexer tree, and the problems based on this multiplexer tree we are going to discuss in the next lecture, by which you can get concept cleared what exactly the multiplexer tree is. Thank you.